All right, it's time to start class. What questions do you have? Do you guys know where the videos are? You go to Carmen, and then there's like a content button, right? And then there should be all the way to Wednesday's videos up now. So that's pretty good. I'm getting better. Yes? One of my math lab problems. Which one? Let's do that one. We haven't done that one yet. So the derivative d over dx of natural log of oops. Like so? All right, this is the problem I'm doing. Hopefully it's the right one, right? All right, so we have to take this derivative somehow. Now, remember, there's sort of a shortcut with natural log, right? And you can write the derivative of the thing inside over the thing inside. So this is going to equal, well, I don't know, but we're going to have this big, I call it a fraction bar. I have no idea what this thing's called. Over x plus 2 over x minus 2, right? And now we have to take the derivative of this thing right here. Oh, this guy's smart. He has a better idea. Okay, so I'm gonna renege on what I did here. This is yeah, okay. So he says take this back. I'm sorry. He says Bart, that's stupid. Bart, what you should do is use log rules. Log, she's nodding her head. She says, I knew that, Bart. How is this going to watch you do this the stupid way? No, I'm just kidding. I'll see what happens. Well, we'll see what happens, okay? We'll see what happens. So use log rules. That's the best thing to do. So this is equal to the derivative, equals d over dx of natural log of x plus 2 minus natural log of x minus 2. Aha, this is much better, right? And so now this is equal to, good point, something over x plus 2 minus something over x minus 2. And what's the derivative of x plus 2? 1. What's the derivative of x minus 2? 1. She says, that's what I put in and I got it wrong. I don't know. My math lab, the crowd is telling me that my math lab makes you simplify this. Okay, so let's go ahead and simplify this, if that's all right with everybody. Or I will attempt to simplify. So what do we have to do? We got to put it over a common denominator, right? And so that's going to be over x plus 2 times x minus 2, right? And now, this becomes x minus 2 minus x plus 2. Is that correct? I found a mistake with my last video, but you guys all made it with me. But then I figured out how to annotate it with the YouTube little bubble thing. And so you can see, you can watch. That's exciting. X minus 2 times, or plus 2 times x minus 2. And what do we get here? The x's are going to cancel and we'll get minus 4. Good? Is that simplified enough? She says yes. And everybody's saying yes. All right. Yeah?
I have a question from the next lab.
Yeah? Which one? Inverse cotangent. What's the derivative of inverse cotangent? Negative 1 over 1 plus x squared. So dx of cotangent Like this? Wait, no, not negative. Arc cotangent is what you want, right?
Yeah.
Yeah. Arc cotangent. That's okay. I did it right with you. All right. So arc cotangent of x is what's this equal to again? 1 plus x squared?
With the question that they had, it was
Arc cotangent of the square root of 6z. Are you taking the derivative with respect to z there?
Yeah.
So this is what the crowd told me right here. I believe them, I guess. D over dz of arc cotangent of, what is it again? Whoa. You gotta, I lost it all. So the
So there's a 5 in front of
I'll put the 5 right here. It doesn't matter.
yeah. And then it's square root of
6z,
yeah.
right there, and like that. Does anybody else remember this problem?
This is from the next one.
I'm not doing your homework. I mean, I will do it right here, but all right. Okay, so what rule do we have to use? Chain rule. We got to use the constant multiple rule first, right? That's how we got this 5 out here. The 5 was in here, but we pulled it out. I pulled it out first because I didn't want to erase everything. Hope that's all right with everybody. Okay, so we got to use the chain rule. So this is going to equal 5 times minus 1 plus square root 6z squared times the derivative of the inside. The inside is square root of 6z, so that's going to be, well, it's going to be 1/2 times 6z to the minus 1/2 times the derivative of the inside one more time, the 6 times 6. Does anybody think that's right? Yeah? Okay, some people are not, that sounds good. Okay, good. What do you think? Is that okay?
Yeah.
Okay. Oh, this guy's asking a great question. Is there ever a problem where you have, so if we just start composing functions together, it's possible to create functions that aren't defined anywhere. You know, like if I wanted to write something like natural log of minus x squared. Can you take the natural log of a negative number? You get a complex number out, but typically in this class you don't. So this would be an ill-formed problem in our class. Now you guys could still differentiate it. You wouldn't have any problem doing that, and your answer would be essentially correct. But yeah, you can have domain problems. He says, do you have to check? No, you guys ignore these domain problems, okay? You leave the domain problems up to us, and then you can write us snide comments if we get confused. Dear Bart, nice example. Too bad it doesn't exist anywhere. You know, that sort of thing. Yeah, hopefully I don't do that. Yeah, I'm erasing. Okay, so somebody asked me about this implicit differentiation slope at a point earlier. I'm not going to do it again, but I did it online. If you want to know where exactly it is online, send me an email, and I'll send you the link to the video. Okay. All right, let's move on. Let's move on to the related rates problems. These might be the hardest problems of this class. I'm not sure. I think they're certainly the most, you know, if I was going to say what's the most, you know, if I could make you do any problem If you guys can solve these related rates problems, that's pretty awesome. We should do all of them. How do you guys study for the exam? How do you study for the exam? You gotta work problems. Is it enough to look at somebody's solutions to a problems? No, that is unhelpful. That would be like, I want to go play a soccer match, and my idea of practicing is watching soccer on TV. Is that gonna help? Yes, yes. No, it will not help. Okay, that's not going to help. You have to do it yourself. Watching me is only going to help a little bit, really. You know, I might be able to get you a little bit further, give you some ideas, but doing it yourself is the best. So related rates. So I'm going to follow a little procedure here. And here's the procedure that I'm going to try to follow every time. First, I'm going to always try to draw a picture. I'm always going to try to draw a picture if I can. I'll draw a picture and see what happens. The next thing I'll try to do is I'll try to find an equation. I'm always going to try to do this, try to write down an equation. An equation is something with an equal sign, right? Right? So of course I know that part. Yeah, okay. Next, I'm going to differentiate the equation. What does the word differentiate mean? Take the derivative. It doesn't mean what it sounds like. It means, you know, tell it apart or something. You know, I can't differentiate between these two pieces of chalk, between this piece of chalk and the leading brand. You know, and well, whatever. Okay, so differentiate the equation, and then the final thing that I want to do is evaluate at desired values. So evaluate at desired values. All right, so these might not make much sense to you right now, but what we're going to do is we're going to work a bunch of examples, and I'll try to very clearly show you how I'm applying each of these steps. All right, so the first, you know what? I'd planned something else, but now that I'm standing here, I want to do it a different way. Yeah, let's do this. Okay, so you have a cylindrical tank. These are all word problems, and they're all a little bit different, but they're not too bad. So so this is our first one, a cylindrical tank. A cylindrical tank. It's a thing of water, okay, and it's draining. Okay, it has a radius of 20 centimeters. Okay, great. And how fast is the water level in the tank dropping? Okay, how fast does the water level drop if water's being drained at 25 cubic centimeters per second? If water is being drained at 25 centimeters cubed per second. So now look, what you have is you have this tank, you have water in it, water's coming out at a rate that's given in a volume. And you want to know how the height of the water is changing. It's related rates. The one is the rate of the volume is changing, and the other one is the rate of the height of the water is changing. So what's step one? Step one is draw a picture. Draw a picture. This will be the pink step. Draw a picture. Okay, so by the way, I may not be phrasing these questions in the most detailed way. That's because I'm going to draw a picture and I'm talking and I can be explaining it to you as we go along. So draw a picture. So a cylinder looks like this. Here's our cylinder, right? And there's a hole in the bottom of the cylinder. There's the hole, and and water is gushing out at what? 25 centimeters cubed per second. By the way, don't get too artistic with your pictures. I remember once I was taking a test and I was given a problem and I drew all kinds of things in this picture. And then I figured out I didn't know how to do it after I drew the picture, and I just felt so stupid, you know. So just don't do that. So here's the water level. Here's the water level. Oh, and what's the radius? The radius is 25. Oh, it's 20 centimeters. And we want to know how the height. What the height is changing. So I'm going to call this right here h. We want to know how height is changing. So draw a picture. There it is. Draw a picture. Does that make sense to anybody? Okay, great. Next, we got to find an equation. Find an equation. I got to relate everything I see here somehow. It may not be clear. This is the hard part because you have to kind of look for something. You have to write down an equation that doesn't exactly tell you what you want to know. I want to know how the height is changing, but I'm not going to write that down. What I'm going to do is I'm going to write an equation for the volume. So the volume is equal to, this is the volume in cubic centimeters. Does anybody know how to find the volume of a cylinder? Yeah, pi r squared h. It makes sense because pi r squared is the area of the circle, and then you're h'ing it, right, to move it up and down, right? So it's pi times 20 times, pi r squared, 20 squared times h. This is our equation. This is our equation. Now, the next step is differentiate the equation. So, differentiate the equation. We're going to differentiate the equation. Okay, so now we use implicit differentiation. Now remember, implicit differentiation is just the chain rule. It's pretending that all these things are functions of time. Boy, time's the strangest thing in the universe. So if I want to differentiate this thing, the derivative of, I want to see how they write this. I don't want it to be too different from how you guys, I want to be kind of similar. Okay, good. Volume is changing with respect to time, right? The rate is 20. So we're going to write, if I differentiate, it's going to be v prime of t. I'm putting t's everywhere. I hope that doesn't bother anybody. Equals pi times 20 squared times h prime of t. Do we know v prime of t? Yeah. So now we'll do this last one. Evaluate at desired values. Okay, evaluate the value. I'm just going to write evaluate. All right, so evaluate. So now I know v prime of t. It's 25. 25 is equal to pi times 20 squared times h prime of t. Now we can solve for h prime of t. Check this out. So 25. How do you somebody factor 20 for me? 20 somebody factor 20. Yeah. Or no, okay, I'll give you the answer. 4 times 5. Okay, 20 is 4 times 5. So when I divide 5 times 5 by 4 times 5 squared, I get 1 over 16 times pi equals h prime of t. Right? I just divided 25. This is 5 times 5, divided by 4 times 5, divided by 4 times 5. So now the 5's cancel, it's 4 times 4, which is 16. And then the pi's there too. So the height is changing. Oh. The height, is it going up or is it going down? Down. And if I would have put this as a negative 25, then we would have that minus sign there. But I didn't. It's okay. So it's going down. The height is decreasing at a rate of 1 over 16 pi centimeters per second. What do you guys think? This example, not too bad? Can you guys ask me a question? All I'll do is try to answer it better. Where did I get the 25? Outstanding question. So this is the volume in centimeters and cubic centimeters. Right? You with me? Awesome. This is the rate, the volume is changing as time changes. And see, water is gushing out at 25 centimeters cubed per second. So this is the rate that it's changing, so I replaced it with 25. What do you guys think? Questions? All right, let's do another problem. Here we go. Here's the most famous. This next problem is the most famous related to rates question ever. Okay, so a ladder that's 13. How long is 13 meters? Yeah, it's like almost 40 feet, right? It's a giant ladder, a 40-foot ladder. Rest on some ground, okay, is against a wall. It's against a wall. And it's being pulled away from the bottom. Being pulled away. From the bottom of the wall, so it's like leaning like this, and you're pulling it away at 0.6 meters per second. How fast is the top sliding down when you're 5 meters away from the wall? How fast is the top sliding down when 5 meters away from wall? Okay, so if this doesn't make any sense, that's okay. I'm going to draw a picture and hopefully make it make some sense. So let's see. We got to draw a picture first, if possible. Draw a picture first. So here's the wall. Here's the ground. And then we have a ladder. Here's the ladder. I know it looks like a line, but it's a ladder from the side. Right? It's a ladder from the side, like this. And what we're doing is we're pulling this out right here. Pulling it out like that at a rate of 0.6 meters per second. And we want to know, and by the way, this is supposed to be, that's supposed to be 5 meters right there. 5 meters. And we want to know how fast is the ladder going down. That's what we want to know. So I'm pulling this ladder out, and somehow it's going to be doing this. That's the idea. Draw a picture. Picture's drawn. Find an equation. All right, let's find an equation. What famous theorem of mathematics do you think we're going to use? We're going to use the Pythagorean Theorem because this is a right triangle. And almost, you try to use the Pythagorean Theorem as much as you can in any of these related rates problems. Find an equation. All right, okay. Think, Bart. Think. Oh, yeah. So what you should do is you should call this maybe y of t, and you call this one x of t. So x of t is the position here, and y of t is this direction. And so now, and how long is the ladder? It's 13 meters. It's an unbelievable 13 meters. There we go, 13 meters. So, yeah, x of t squared plus y of t squared is equal to 13 squared. All right. So, fine, I got the equation. Bam. Next I'm supposed to differentiate this equation. Will do. Going to differentiate it. Here I go. The derivative of x of t is just x prime, so it's going to be 2x prime of t plus 2y prime of t. What's the derivative of 13 squared? 0 equals 0. You say, I still don't see how the answer is going to come out of this. So now we evaluate. We plug in all the numbers we know, and we see what happens. All right, so look, here, I know something here. Well, do I even need to know anything there? I don't know what I'm looking for. I want to know y prime. Oh, and I did the derivative wrong. That's right. All right, erase all this garbage. Yeah, sorry. What rule did I not apply? Chain rule. So that's going to be 2x of t times x prime of t, make your prime correctly, Bart, plus 2y of t times y prime of t equals 0. There we go. I'm sorry, everybody. My apologies. But I fixed it. There we go. So now we need to know x of t and y of t. Now look, I know x of t. X of t it's just 5. So that's going to be 2. There's my equation. So now I'm just going to start evaluating it. It's 2 times 5. What's x prime of t? Times 0.6 plus 2 times, now y of t I don't know, but what can I do? I can use my Pythagorean theorem to figure it out. So I have 5 squared plus y squared equals 13 squared, and 5 squared, what's 13 squared is 169. 5 squared is 25. Plus y squared is equal to this. So now I subtract 25 from both sides, and I get y squared equals 144. So that tells me that y is equal to plus or minus 12, but y has to equal plus 12 because it can't be minus 12. So 2 times 12 times y prime of t, that's equal to 0. Whew. Oh, but now look what we can do. Can we solve for y prime of t at this point? Yeah, we can solve for y prime of t. So first thing I'm going to do is, what's 2 times 5? It's 10. What's 10 times 0.6? 6. So that's going to be minus 6. So I have 2 times 12 y prime of t is equal to negative 6. 2 times 12 is 24. 6. Wow. Y prime of t is equal to negative 6 over 24 is equal to minus 1/4. And what are the units on this? Does anybody know? Meters per second. Meters per second. Does that make sense? Negative 1/4. Oh, if I move this out, what way should this be? Yeah, y should be decreasing. That makes sense. What questions do you have? So this is the final answer. What questions do you all have about this? All right. Are we ready to do another example? We've got like 5 of them or so. Let's do another example. This one slightly harder than the last, but not too much. All right. So here we have, let's see, an airplane is flying away from you at 500 miles per hour. At an altitude of 3 miles. How fast is the distance between you and the plane increasing? How fast is the distance between you and the plane increasing when the plane is over a point 4 miles away from you? Okay, so here's what I'm going to do. I'm going to draw a picture just to make sure everybody knows what the problem's asking. And then I'm going to give you guys a second to write down your own equation. And I want you to do it, and then we can kind of compare. It's not going to help just always looking at mine. You guys can draw a picture if you want to, but we'll back up to that. We'll work up to that one. So here's a good picture. So here we are. Boop, there's us. And here's 4 miles. There's 4 miles. And the altitude of the plane is 3 miles. And how fast is the plane moving? That's supposed to be, there we go, that's an airplane. It's traveling at 500 miles per hour. And what we want to know, the thing that we want to know is this right here. And that's what we want to know. I'm going to call this S of t. There we go. That's going to be S of t for distance. And I'll give you one more hint. Plane's traveling at 500 miles per hour, so this is a rate. So this will be P prime. That's P prime of t. P prime of t is this. It's how fast the plane's going this way. So can you write down an equation here? It's a little bit tricky. These problems are not easy. Can you write down an equation? Try to do it. I mean, if you don't want to, don't, but that's not helping you at all. Because when the exam comes, you're going to have to write down an equation. Write down an equation. What famous theorem are we going to use, by the way? We're going to use the Pythagorean Theorem somehow. Now, what might be tempting to write down is 4 squared plus 3 squared equals s squared. That might be really tempting to write down. It's not going to get us very far, though, okay? It's not going to get us very far. What is 4? 4 is, what is 4 again? How far away the plane is. So this is like P of some time. This is P prime. So what's going to help is if you do this. If you have S of t squared is equal to 3 squared plus P of t squared. Whatever's changing, you want to have its, before it changed, function inside your equation someplace. All right, so here's our equation. And now, what do we do next? What do we do? We got to differentiate this. Take its derivative. All right, let's take the derivative. See what happens. So, one way that you know you're on the right path is when you differentiate, you should see one of these derivatives that you know. So look, it's going to be 2 times s of t times s prime of t equal to, well, the derivative of 3 squared is 0 plus 2 times p of t times p prime of t. Ha-ha, so there's that p prime. So look, I can start to fill this in already. So 2 times s of t I don't know yet. So s of t and s prime, that's what I want to know. I don't know that yet. But I do know p of t. What's p of t equal to? 4. And p prime is 500. 2 times 4 is 8 times 500. Oh, 8 times 5 is 40, right? So this thing's equal to 4,000, is that right? 4,000? All right, so if only we knew S of t. Well, can we find S of t? Yeah, we use Pythagorean Theorem. So S of t squared is equal to 9 plus, you plug in 4 here, right? From here to here. 16, well, 9 plus 16 is? S of t is equal to 5. So this is 2 times 5 times S prime of t. 2 times 5 is 10. This is a beautiful problem. Everything's working out really nicely. S of t is equal to 400. And what are the units on this thing here? Miles per hour. And does that make any sense why this should be changing, why this should be changing at 400 miles per hour? Can anybody give me some indication why that might be right? Yeah?
Because that 500 is the same as like 400 below.
Yeah! So if you were floating in air, it'd be going, the distance would be increasing more, right? Here, than if you're here. Because, like, think about like when the plane's right above you. The distance isn't increasing very much at all, right? So it makes sense it's a little less than 500. That sounds good. What questions do you guys have about this? All right, let's do another one. Here we go. How are you going to ensure, I mean, look, do you think there's going to be a related rates question on your exam? Yes, there will be. There will be, okay? There will be a related rates question. There will be an implicit differentiation question. There will probably be a logarithmic differentiation question. There will probably be several, just compute these derivatives. To me, that sounds like the whole exam. I mean, these are not, I don't see why these are secrets. You know, it's like, what else could be on it, really? So, what should you do? You should do every related rates problem in the book. Okay, fine. Start with the odd ones. And then after you do all the odd ones, do all the even ones. Right? And then when that related rates problem comes, you just say, I dare you to put a related rates question on this exam because I will just answer it correctly and you won't be able to trick me. Right? That's what you say. That's what I want you to say anyways. All right, so here we go. Where's the statement of the question? Ooh. Here it is. You're inflating a spherical balloon. So you inflate a balloon. At a rate of 7 centimeters cubed per second. So you're inflating a balloon. How fast is its radius increasing? How fast is the radius increasing? When the radius is 4 centimeters. A spherical balloon. Yeah. Spherical. When it is 4 centimeters. So we start by drawing a picture. And I'm going to give you guys a hint. So I'm going to ask you guys to draw this picture. So you should try to draw this picture. And I'm going to give you a big hint on how to solve this problem. Okay, here's a huge hint. It's the volume. It's the formula for the volume of a sphere. The volume of a sphere is equal to 4/3 pi r cubed. That's the worst penmanship ever. There we go. 4/3 pi arc. That's the volume of a sphere. So try to draw a picture. Okay, try to draw a picture. I'm going to give you guys like 30 seconds. It's not too long to ask you to draw a picture. You should just humor me for your own sake. Draw a picture. What's it going to look like? All right, I'm going to try to draw this picture now. So you're going to draw, it's obviously going to be a sphere. You're going to draw a sphere of some sort. You draw spheres like this. That's how you draw a sphere. Looks great. And we know it's radius, so that should be on there someplace. All the information somehow should somehow be in your picture. There's that radius right there. 4 centimeters. Here, I'll color my sphere in. And how fast is the volume changing? Oh, 7 centimeters cubed per second. So volume prime of T is equal to 7. It's getting bigger, right? And we know that volume is equal to 4 pi r cubed over 3. Good news. The next part of the problem is simple. Find an equation. We already have it. It's right here. This is going to be, this is the equation we'll use. We'll use this volume equation. So that's not hard at all. I'll write it one more time. V of t is equal to 4/3 pi r of t cubed. Now we need to differentiate the equation. All right. V prime of t is equal to, let's see here. Well, the constants are going to stay out. And then what do? Times 3 r of t squared times r prime of t. And so now we need to evaluate this thing. And look, almost everything we have, we know. So v prime of t, that's equal to 7. These 3's cancel. 7 is equal to 4 pi. Oh, what's r of t equal to? 4 times 4 squared times r prime of t. We are basically done at this point, but let's go ahead and solve. So this is going to be 7 over, what's 4 cubed? 4 squared is 16. 16 times 4 is, what's 16 times? 64. Okay, so good. So 64, that's 7 over 64 pi. And then that's equal to r prime of t. What are the units on this thing here? Centimeters per second. Centimeters per second. cm per second. It's a rate. That's how the radius is changing. Not too bad, right? Let's see, what time is it? It's 2:40. What time do I usually end class? Alarm. All right, well, it's Friday. We got not enough time to do another problem. So we'll end for today.